see what happens. It says that it's loading, but we'll see what happens. So hi everybody. Today I'd like to show you some of my favorite chemical experiments and reactions, and in the process hopefully convince you that not only is chemistry not boring, but in fact it is one of the most fascinating subjects. So with that, let us begin. So first, and it still says it's loading, so I don't know what I'm going to do. But so the first reaction is with a substance called luminol. Now, luminol glows when it reacts with certain chemicals. One of these certain chemicals is hydrogen peroxide. Hydrogen peroxide, when reacting with luminol, steals a couple of hydrogen atoms from luminol, and we get a new form. Then this new form will react with oxygen, and this will result in an unstable molecule. So from normal state, our substance will get to an excited state. And eventually it has to return to normal state because excited state is unstable, and in the process it will emit energy in the form of light. And I'd also like to mention that luminol is used at crime scenes because this reaction also happens with iron, and your blood contains iron. So let's see the reaction. So we mix, yeah, it doesn't even start. Maybe it will start like this. Yes. So we mix luminol with hydrogen peroxide. Our substance gets to an excited state, and then the video stops now. So we slowly get back to normal state from the excited state. Of course, luminol glows, but it glows less and less, and now it's returned to normal state and it's dark again. Now this next reaction is also with luminol, but note that there's some added chemicals there, also including a catalyst. So this will look much better. Maybe the videos are going to load in like this. Basically the same thing, but with some added chemicals, so it will look better. What I'm going to do is I'm going to go full screen again, and when I play a video, I'll exit full screen. Hopefully the videos will load in like that. So moving on, we have the Briggs-Roche reaction. So we have three colorless solutions. Not going to name them. There's quite many of them. The point is that these three solutions are all colorless on their own. We mix them together in a single container, and we put an oscillator at the bottom, which will keep spinning and spinning. And first, the solution will remain colorless, but then it would change to yellow and then to dark blue. So why does that happen? Well, what happens is that iodine keeps changing its form. And when it's iodide, a negatively charged version of iodine dominates, we'll have a colorless solution. When we have iodine dominating, the solution will be yellow. And then triiodide dominates, we'll have a dark blue solution. And never lucky. Never lucky. Yes, so we have the colorless solution. We mix the three solutions together. Now iodine dominates. Now triiodide dominates. And the solution will slowly return, or rather quickly return to a colorless section. But the colorless section will be very brief, so watch out for it. So colorless, and then yellow again. And then it will turn dark blue again. And this keeps on going for a while, but eventually it will come to a halt. Yes, of course, the typical sugar with sulfuric acid reaction. So what is sugar? Sugar is basically carbon rings with hydrogen and oxygen atoms attached. And what sulfuric acid does is pull off these hydrogen and oxygen atoms. And so what we'll have left is just these carbon rings. and that will result in a solid column of graphite foam and also some gases, among them the poisonous sulfur dioxide. So let's see the reaction, and I'll exit full screen. Let's see what happens. So we've already mixed sugar with sulfuric acid. This is what you see.
Go ahead and make sure that
And
just move
the column of graphite foam comes out. And you can see the gases leaving the system. Among them, the poisonous sulfur dioxide. So this is basically it. Now, moving on, we have the elephant's toothpaste. It is quite a popular experiment. It involves soap, hydrogen peroxide, and I'm going to wait for that for a little bit. So hydrogen peroxide breaks down into water and oxygen. The now soapy water traps this oxygen, which will create bubbles, resulting in foam. But what you'll see that in the beginning the reaction will be very slow, so we need to add the catalyst. Now, a catalyst is something that speeds up a chemical reaction. In this case, it is potassium iodide. So now, when they've added the catalyst, the tower of foam will grow very fast and it will look quite good, I think. So, this is hydrogen peroxide in the tubes. They add food coloring, so it looks better. This is food coloring. They add in soap, and the reaction starts, but it's very slow. You can barely see anything. It's not worth mentioning. But now they add the catalyst, which is going to speed up the reaction. And this is what you see. So again, hydrogen peroxide broke down into oxygen and water. The soapy water trapped the oxygen, which resulted in this foam. Moving on, we have a single replacement reaction. I chose the typical copper sulfate solution, and we're going to put an iron rod in it. So what we see is that, first of all, when copper dissolves in water, we'll see, or we're not going to see, but the copper ions are going to be floating around the liquid. So copper ions are, of course, positively charged. When we put in the iron rod, the iron can give a bit of a negative charge to these positively charged copper atoms, so the non-neutral atoms will no longer dissolve in water and will get back our copper. This is what happens. We get back our copper. Now note that this reaction is sped up, but it happens just like this. So this is the copper sulfate solution, this is the iron rod, and the non-neutral atoms no longer dissolve in the water. And last we have the ferro snake, which involves the burning of some mercury thiocyanate. And I'm not going to go into details what happens, but basically while burning, the atoms rearrange. And we'll see a twisting column of ash that's going to grow from the burning powder. Also note that this used to be sold as a basic firework for children, but later on we realized that kind of everything is hazardous about this, so maybe we shouldn't sell this to people, especially not to children. But it is still fun and it's worthy of mention. So this is mercury thiocyanate. We start burning it, and in the beginning this is quite slow. The column of ash rises slowly, but it will speed up eventually. And it sort of looks like a snake, sort of. And when we've used up all the mercury thiocyanate. The reaction, of course, comes to a halt. Now, this is mostly made out of carbon and sulfur. And we've come to a halt. So I hope I managed to convince at least some of you that chemistry is not all that bad. And I also hope that you've enjoyed these little experiments. So thank you for your attention.